Welcome to the Massachusetts School of Law Educational Forum. Thank you for joining us. This program is brought to you by the Massachusetts School of Law and is shown nationwide. The topic for today's show is the Arctic Climate Impact Assessment. Global warming is here and now. What can be done about it? Global warming and its effects are here, and the effects are bound to get worse. As pointed out in April 2002 by Margaret Beckett, British Secretary of State for the Environment, quote, "We've known for some time that we have to worry about the impacts of climate change on our children's and grandchildren's generations, but we now have to worry about ourselves as well," end quote. In the hour that follows, we will first explore why skeptics either continue to deny that global warming exists or point to the many benefits that will supposedly accrue to the Earth and its inhabitants because of a warming planet. We will next consider the effects of warming on plants, animals, and other living things in the Arctic and elsewhere. Last, we will investigate corporate and governmental opposition to change and possible policy prescriptions for change. Joining me for this discussion are Professor James J. McCarthy of Harvard University. Professor McCarthy was head of a working group of the Intergovernmental Panel on Climate Change. He was co-chair of the IPCC, and he was one of two lead authors for Science Chapter 17 of the Arctic Climate Impact Assessment, Climate Change in the Context of Multiple Stressors and Resilience. That was a mouthful. Thanks for joining us, Jim. Professor Paul R. Epstein, MD, is an instructor in medicine at Harvard Medical School. He is widely published with expertise in marine ecosystems, infectious diseases, and global climate change. Thank you, Paul. And Ross Gelspan is a Pulitzer Prize-winning journalist and author of The Heat is On and Boiling Point: How Politicians, Big Oil and Coal, Journalists, and Activists Have Fueled the Climate Crisis and What We Can Do to Avert Disaster. Thanks for joining us, Ross. And I'm Kurt Olson, professor at the Massachusetts School of Law and host for today's program. Jim, could you explain a little bit about the Intergovernmental Panel on Climate Change, the IPCC?
That mouthful is an organization that came into being in the late 1980s. It was a period when many scientists were beginning to see what they thought were very clear signals that the Earth's climate was changing. But it's difficult to interpret a lot of that information. And it was decided by a couple of UN bodies, the World Meteorological Organization and the United Nations Environmental Program, that it would be good to bring a group of scientists together to look at all the information and to see if we could collectively come up with a clear statement that might be useful to decision makers. And this was a very important product, the first IPCC report in 1990. Leading into the discussions in 1992, culminating in Rio with the signing and ultimately the ratification of the UN Framework Convention on Climate Change. This body, which includes about 100 nations, is asked in each round. It had a second assessment in 1995, a third one in 2001, and a fourth one is underway now. Each of the 100 or so participating nations are asked to suggest scientists who would be authors, who would contribute to this analysis and be authors of the final report. The report in its last version, the third assessment, 2001, involved as authors, as reviewers, a couple of thousand scientists. It's a report that is looked to not only by governments but by decision makers in industry as well for the current understanding, the current state of what we know about climate change.
Thank you. And can you explain a little bit about how the Arctic Climate Impact Assessment got started? Is that connected in some way to the IPCC, and exactly what has that found?
Its roots could be traced to the IPCC in that beginning in the mid-90s and then repeated again in 2001, the IPCC process included a breakdown by regions. In other words, we have a global picture, but what might be some of the manifestations of this global change region by region? And so in 2001, for example, there is a chapter that deals with impacts of the projected global climate change in the polar regions. Now, the polar regions, North Polar region, South Polar region, are very different. The North Polar region is geographically different, but also it's one where a lot of people live, versus the South Polar region, which is not occupied by, there are no indigenous people, and occupied only by scientists today. So it was thought that it would be it would be wise to begin to look intensively at particular regions and regions that might be subject to substantial change. And the Arctic is one of those regions that popped out as being one where some of these changes might be the largest. So a group, actually two groups, one called the Arctic Council, which is a high-level representation of the 8 Arctic nations, and observer status for a few other nations like France, UK, Netherlands, and Poland. And then 6 global, or 6 pan-Arctic groups of indigenous people came together to formulate the strategy for the Arctic Climate Impact Assessment. And in the process, like the IPCC, I ask all of the participating governments to nominate scientists who would be authors for this report.
I see. Thank you. Paul, a friend recently asked me, if you're so convinced that the Earth is going to end, the world's going to end, why did you have a son a few years ago? Is it something that you have a death wish for him, or are you just worried about what might happen in the future? Can you do anything to put my mind at ease, or is this just something where I have to say I'm worried about the type of world that my son might grow up in?
Well, I think we are worried about the type of world that your son is going to grow up in, and not necessarily that the world is going to end, but that it is changing. And I wish I could be Pollyannish and reassure you, I have a son and a grandson, and I am concerned. At the same time, I think that the reality, as it's rapidly evolving, will also affect our responses, our consciousness. And just as systems can reach tipping points, as Malcolm Gladwell has informed us in his book on that, by that title, so can the awareness and consciousness about the true impacts of climate change, the true cost to society, and the potential for dramatic changes in the system. So I am concerned, but at the same time, I think that awareness can precede the changes that we're afraid of.
Thank you. Russ, does the Bush administration have it all wrong? In other words, specifically a December 5th Washington Post article said that the administration has decided to focus on, quote, technological fixes, developing energy sources that burn cleaner, or finding ways to extract excess carbon dioxide out of the atmosphere. Undersecretary of State for Global Affairs Paula Dobriansky is quoted as saying, quote, our approach is founded on sound science and on trying to address with different strategies climate change. Is what she says all wrong?
Yes, it is, Kurt, unfortunately. Let me put this in context a little bit. What the IPCC, as Jim described it, basically reviews the work of more than 2,000 scientists from 100 countries in what is the largest and most rigorously peer-reviewed scientific collaboration in history. The IPCC has determined for at least the last 9 years that in order to allow the climate to restabilize, humanity worldwide has to cut its use of fossil fuels, of coal and oil, by about 70%. And the administration is nowhere near that. The administration is trying to finesse this, I think, with a lot of sort of cosmetic and very ineffectual mechanisms. I think if you look at what the countries of Europe are doing, you're seeing that they're much more driven by sound science. Holland has just finished a plan to cut her emissions by 80% in 40 years. Tony Blair has committed the UK to cut emissions by 60% in 50 years. The Germans have committed to cuts of 50% in 50 years. By contrast, just to wrap up this question, at this last round of climate talks in Buenos Aires in December 2004, the United States not only did not participate in the talks, they sabotaged the next round of talks so that when the delegates meet again in May to discuss the next round of the Kyoto Protocol, because of machinations by the Bush administration, they will be prevented from talking about any actionable measures at all. They're confined to simply having a seminar. So I think if you look at what the scientific consensus on the magnitude of the problem is and what the Bush administration is doing, it's not at all based on sound science.
Thank you. Jim, in The Heat is On and Boiling Point, Ross's two books, he spends an awful lot of ink discussing how the oil and coal lobbies have done everything that they really can to demean the work of the IPCC, the UN, and any other organizations doing research on climate change, suggesting, in fact, that the IPCC and the ASHA assessments are based on what they call, quote, junk science, end quote. When you hear junk science in the context of global warming, what do you think?
Well, I have to laugh. Unfortunately, as you know, Kurt, the process of science is not something that that people far away from the field of science fully appreciate. And those who would use the term junk science are simply attaching a label to something that they don't like. It doesn't in any way reflect an analysis of theirs which would say the science was flawed. The methods that were used were poor, the analysis was poor, the conclusions can't be supported. The people who use that term don't then provide an alternative which would say, here is the science that you have overlooked that would explain a phenomenon that you are attempting to explain with science that is in some way flawed. So it's a pejorative term that is thrown about by the people who would not like the science that has been put forward to be accepted.
I think that connects in some way to what Ross said earlier about the peer review process. I was wondering exactly what that is, if you can explain how what the IPCC has done and what ASHA reflects is peer reviewed, whereas the science of those who would oppose you is not necessarily peer reviewed.
The IPCC and the Arctic Climate Impact Assessment did not generate any new science. They review the published literature. They review all of the science that is on the table and the journals, the books, and particularly in the case of the IPCC to update the findings from the previous one. And in the course of that, there will be a range of positions represented in that science. We can talk about some of that later, maybe about how much climate may change in the future. And what the IPCC and the Arctic Climate Impact Assessment does is to take a very conservative view. What are we really confident that we know well? Now, that foundation is all comes from the peer-reviewed science. Someone can't walk into one of these meetings and say, well, I've got an idea, let's put that in the report. It doesn't work that way. You've got to say, where are the citations? And the standard in our community is to use journals where every submitted paper has been reviewed by other scientists to look for flaws, to vet its quality, and only after it goes through that process, and certainly a lot of papers are submitted never get published because they are found to have flaws. Only after going through that process is something then on the table to be considered in this analysis.
I see, thank you. Paul, how do you respond to John R. Christie, atmospheric science professor at, I think, the University of Huntsville in Alabama, who said, excuse me, in the same Washington Post article, quote, the Bush administration is doing a more reasonable approach, considering that mandating carbon restrictions will have no measurable effect on what the climate will do, end quote.
Well, first of all, Kurt, let me say I'm pleased that scientists are entering the policy debate. However, we are dealing with a very large system of our energy past and present policies. And to move that donkey, as it were, we're going to need carrots and sticks. Now, the Bush administration has provided some carrots for clean energy technology development. Small, several tens of, perhaps even $100 million. As Ross has explained in his books, and we're going to need tens of billions of dollars to provide movement once we kick the donkey. The mandatory issues are necessary to constrain how the donkey moves. We're going to need incentives to provide that fuel for the movement. These are the components that are needed to go together. Without the two of them, without the mandatory, without the proper magnitude of incentives, we're not going to see a real new energy policy that is what we need to get us out of where we're going.
I see. And how do you respond to, Christie also said in the same article, he said that 1937 and 1938 were in fact the warmest Arctic years, and that Greenland temperatures are not hotter than they were 75 years ago. How do you respond to those kind of statements?
This is the kind of science that picks out little blips in long-term trajectories. And it may be that 37, 38 were hot years. What we are now in since the late 70s and mid-70s is a sustained period of warming that is accelerating. We are seeing the rate of warming increase. Indeed, we're seeing so much warming near the poles, as the Arctic Climate Impact Assessment describes, that we're seeing warming, thawing of ice, melting of ice, and changes in ocean temperatures, potential changes in ocean circulation. So that it's the sustained warming period that we're in right now that's having the long-term impacts on the ice, the ecological systems, on the health, on the society of the people living there, and indeed with implications for the global climate system.
Thank you. Ross, last question to you before the break. The same Washington Post article quoted Myron Ebell of the Competitive Enterprise Institute as saying that some studies cast doubt on the UN pronouncement in 2001 that the 20th century was likely the warmest in a millennium. What is the Competitive Enterprise Institute, and are there any ties to the fossil fuel industry?
There are indeed, Kurt. Let me step back for a quick second. Just speaking personally, my background is not in science. I'm an investigative reporter. I got into this issue because I found out that the coal industry was paying some scientists under the table to say that climate change is not happening. The coal industry was the largest such funder for a while, and they've been taken over now by ExxonMobil, which is now the biggest funder of climate skeptics. As a matter of fact, ExxonMobil since 1998 has spent $13 million funding institutions and naysayers, one of which is Myron Ebell and his Competitive Enterprise Institute. So I think, again, from the perspective of a journalist, it's important to step back, and what you're seeing is a titanic clash of interests in which Ebell is a small player and a spokesman. And this clash of interest basically pits the ability of this planet to support civilization versus the survival of one of the largest commercial enterprises in history. Big coal and big oil generate about $1 trillion a year in commerce. They are fighting for their survival in the face of the scientific evidence, and that's the context in which to take this Ebell material.
Thanks very much. We'll have to go to our first break. I appreciate it, and we'll be back with the Massachusetts School of Law Educational Forum in just a minute. Thank you very much.
Misfits in America is the first volume of a quartet called Thine Alabaster City's Gleam, written by the Dean of the Massachusetts School of Law, Lawrence R. Velvel. Misfits in America, like the entire quartet, is a collection of stories, events, and incidents that illustrate basic problems which arose in America in the last half of the 20th century and continue today. Misfits in America discusses the extensive decline in honesty in our country, the increasing extent to which success is not determined by competence and diligence, the replacement of modesty by celebrification and bragging, the rise of elitism, and the growing concern with one's self to the exclusion of any concern whatsoever with the welfare of others. It also discusses in the national political sphere the gross failure of judges and congressmen to do their constitutional duty, so that we suffered the debacles of Vietnam and now Iraq. Misfits in America has been praised by leading American scholars and authors like Howard Zinn, Amitai Etzioni, Richard Falk, Lyle Denniston, Robert M. O'Neill, and others. It has been called a page-turning account. To obtain a copy of Misfits in America, contact the publisher, the University Press of America, at 4501 Forbes Boulevard, Suite 200, Lanham, Maryland, 20706, at 800-462-6420, or at its website. Or contact the Massachusetts School of Law, 500 Federal Street, Andover, Mass. 01810, 978-681-0800, or at their website, www.mslaw.edu.
And we're back with the Massachusetts School of Law Educational Forum show on the Arctic Climate Impact Assessment and global warming. Jim, could you explain for us the three major mechanisms, the so-called feedbacks, by which the Arctic processes cause additional climate change for the planet?
There are a handful of really important feedbacks. The first is what we would call the reflection feedback. The technical term would be albedo. A white surface, such as a surface of the Earth covered with snow or ice, or ocean covered with snow or ice, will reflect 90 or 95% of the sun's energy that comes to that surface. So it's like a mirror. Mm-hmm. When that ice melts or that snow melts, then the ground or the ocean, rather than reflecting 90 or 95%, will actually absorb 90 or 95%. So the ground becomes warmer, it melts more snow or ice. The ocean becomes warmer, it melts more sea ice. So this is what we call a positive feedback. Once the warming starts, there are mechanisms that help to propel it. So that's the dominant one. There are others that have to do with ocean currents, or others have to do with the thinner atmosphere in the Arctic region, but the one that really influences this tremendously is a reflective feedback.
You mentioned in answer to that question the ocean currents, and I guess that's one of the problems that skeptics have expressed about this whole issue of global climate change, and that is, well, why does it seem that certain areas are getting colder? And can you explain a little something about how ocean currents affect our climate and this whole thing? I guess it's called a thermohaline system.
If I could just for a moment say that I always have to comment on the use of the word skeptic. Mm-hmm. Every good scientist is a superb skeptic. You are constantly asking, do I have this right? Is there another explanation? The whole process of scientific inquiry is one of skepticism. You don't start thinking you know something and set out to prove it. Mm-hmm. You say, well, this is the prevailing wisdom. Can I prove it wrong? That is the way science unfolds. The individuals who don't accept these reports, I tend to refer to them as contrarians. There are other names for them, but they basically are going to take the opposite view of the scientists who are really familiar with this subject. So yes, one of the easy targets for any of these assessments, as Paul said in his last question, say, well, here's an exception. Here's a year that was warmer a while ago. Here's an area of the Arctic that doesn't seem to be warming very much, so how can you make these generalizations? The Arctic is highly varied. You have a massive block of ice in the form of Greenland, which really influences the climate of that part of the Arctic very differently than the low areas around the Bering Sea, for example. Greenland is a block of ice that sits about 2 miles high. If all of Greenland melted, it would raise sea level worldwide about 20 feet. It's a massive amount of ice. So the climate around Greenland will be different than the climate at sea level around the Bering Sea in northern Siberia, for example. And once ice melts from the ocean surface, then not only does it absorb more energy, but it exchanges energy and momentum with the atmosphere. That is, you'll have more wind over that part of the ocean, and the wind and the water interact. So one of the realizations is that as ice leaves the Arctic surface ocean, the surface of the Arctic Ocean, you will have the development of ocean currents that we don't have today on the surface. And one effect of this will be to alter the circulation in the North Atlantic. And that's an area where sea ice is formed now. In the future, it's likely there'll be less. And so you'll have less of this really cold, salty water left behind when the ice forms, and that's what creates this thermo-temperature, haline, salt circulation in the North Atlantic. And that's very much linked to the extension of the Gulf Stream that moves northward now to create a warmer coastal climate in Northern Europe and Scandinavia. So that is very likely to change in the future. There are strong indications that it's changing now.
I see. Thank you. Paul, the ASHA also included a number of different health effects as possible consequences of global warming. Can you point to some of the consequences, especially those that might affect the health of people in the Arctic and possibly elsewhere?
Well, thank you, Kurt. And those of us in the health field, and I think in many biological fields, see the health outcomes of these assessments as the final common pathway that integrate issues of food and water and forestry and wildlife and as marine life, as well as direct health impacts. Some of the direct health impacts for humans that are reviewed in this study include more accidents because of the thinning of the ice, and travel is more difficult and becomes more precarious. Mosquito-borne diseases are moving north, south, as well as to higher altitudes as plants move up, as temperatures change, as the level at which the Earth is frozen all year round is changing, both in latitude and in altitude. As I said, we're going to see food issues, and that's about malnutrition, and that's the most important underpinning for public health. There are water regime changes that are going to affect clean water availability and supplies and quality. Finally, there are a mass of emotional and psychological issues that I think many of those involved in the study were not prepared to face, but have become aware of in discussing the conditions with the native peoples, understanding the changes in their environment, how they can predict what the climate is going to be, how they can adapt to it, how they're going to face dramatically changing conditions.
Thank you. Ross, what about the Montreal Protocol and ozone depletion? From what I understand, I think from reading your book or one of your books, governments came together and actually addressed the issue of ozone depletion over the Arctic and elsewhere. Couldn't that be a model for what governments can do in the future in terms of addressing global warming?
It could, Kurt, and as a matter of fact, to an extent, the Kyoto Protocol is somewhat fashioned on the Montreal Protocol. And under the Montreal Protocol, that dealt with this one class of chemicals that was destroying the ozone layer. So the governments of the world got together, they got the industry to begin to reduce their output of these chemicals, then ultimately to phasing them out. The problem when you transfer that to the area of climate change is the Montreal Protocol dealt with a very small class of solvents and coolant chemicals for which other substitutes were readily available. And in fact, it is a model of success. When you're dealing with the climate issue, you're talking about the world's energy system, which is huge. It's much more pervasive. And while the protocol, the Montreal Protocol, provides sort of a structural beginning for a Kyoto Protocol, the difference is that when you're dealing with the world's energy structures, you're talking about the need to make structural changes in the global economic system. And that's way different and what much larger kind of changes than what was required to simply substitute one class of chemicals for another. So I think we need to go way beyond both the Kyoto and the Montreal Protocols if we're really to achieve some real substantive and meaningful change.
I see.
Could I add a point here that the Montreal Protocol finally included funds and incentives for the transition to non-ozone depleting chemicals? That's an important point to remember in terms of Kyoto.
Absolutely. Jim, a recent report indicates that 2004 was the fourth warmest year on record, and this means that 10 of the warmest years in history, I guess, have happened since 1990. First of all, couldn't that kind of thing be explained by just normal climate fluctuations?
That's the kind of question, Kurt, that scientists are always asking in this sort of analysis. 10 warmest since 1995, warmest since 1998. When you look at the ways that you could affect this sort of change, we've seen it in enormous advances in the sophistication of actually budgeting the Earth's heat sources and losses. And what you can see over the past 15 or so years of research in this, and particularly since 1980, now we have really good data for solar variability because satellites have been orbiting the Earth to measure very precisely the incoming solar radiation. We also have had one very substantial volcano struck the budget over this period and see how much of the warming could come from these factors as well as the greenhouse gas term, the insulation we're putting into the atmosphere. And all of those analyses show that the greenhouse gas term now dominates. Early in the 1900s it didn't. Middle it was back and forth with natural variability. By the end of the 1900s, the greenhouse gas term was dominated. There is no mechanistic explanation that could give you any of those natural variables, solar variability, volcanoes, influencing temperature to this degree in this period.
Thank you. Paul, respected journals like Nature and other scientists have suggested that species loss will be one of the long-term effects and possibly even one of the short-term effects. From what I understand, we're losing species now because of global warming and species having to move further north in order to, I guess, find their natural place. What kind of species are we talking about, and what are the long-term effects of this kind of species loss?
Well, climate change and infectious disease are together stalking species. We're seeing changes in vegetation patterns, movement of zones with climate change. We're also seeing diseases of forests and wildlife move north. West Nile virus, for example, has been present in Canada for the last several years. The range is increasing. That affects wildlife, and wildlife populations can be affected by this disease. We're particularly concerned about the predator populations, the owls, the kestrels, the hawks, that are important in controlling pests such as rodents that carry disease. We're also seeing the forests affected by warming and by pests. Forests, the spruce in Canada and in Alaska have been affected by spruce bark beetles, all the way from New Mexico all the way up to Alaska. The heat reduces the defenses of the trees and is affecting the vegetation. The drought dries the bark rosin that drowns the beetles, and the beetles are emboldened by global warming, getting overwintering, higher latitudes, higher altitudes, more generations per year. So it's the extremes of climate change, along with the gradual warming that is now accelerating, that together are affecting communities of forests, communities of animals, marine life, and we're seeing a period of extinction globally that is affected by climate, infectious disease, and changes in habitat.
Thank you. Ross, one of the things that Paul mentioned earlier as a possible health consequence of global warming was the food shortages and that kind of thing, and how that would affect all of us. Dean Speth of the Yale Forestry School wrote in his book Red Sky at Morning that the population increases have not really been borne out. The problems that we suspected earlier are not going to be as bad as once thought. How do you respond to that? And I guess in your book you actually quoted Mr. Kendall or Dr. Kendall from MIT saying that we would have to worry about how much food we were going to have to produce, and global warming would have a significant effect on this. How does that tie into?
First of all, Kurt, population rates are declining in a lot of areas. They're not declining all over. But this relationship between population and food supplies is very important. There was a report that was put out by Earth Policy Institute last year that basically found that for the first time in human history, for 4 years in a row, the world has consumed more grain than it's produced. And that means that is due to changes in the climate. It's due to the fact that the soil dries out too quickly. We're having more protracted drought, more intense rainfalls, more insect destruction of crops, and so forth. And this trend has already made China, for example, a net importer of food, of grain, which they never were before. This was in the Financial Times about a couple of months ago. So as you're seeing food supplies decrease, that's very, very ominous. In terms of the population side of it, what we think is very important to understand is there are really two things that drive population growth rates. The most important, I think, is economic insecurity. Families in developing countries want to have 8 or 9 kids to make sure that 3 or 4 survive to take care of mom and dad in their old age. And in certain other cultures, it has to do with the empowerment of women. And I think it's useful to look at the population issue in terms of the solution side of the climate change. We're advocating some policies that would rewire the world with clean energy And one of the people we spoke to in developing these solution strategies was an executive director of the World Bank, who made the point that every dollar invested in energy in developing countries creates far more jobs and far more wealth than the same dollar invested in any other sector. And it makes sense. If people in the interiors of poor countries have village solar or biofuels, they can start local businesses and develop local industry and so forth. And that would provide the kind of baseline economic security that would definitely work to bring down population growth rates. So what we're seeing is diminution of food supplies independent of population. And the sort of question is, gee, will the food supplies become so scarce, even if population is declining, that we still will have a much hungrier and resource-hungry world? And that's really what the battle is, sort of a race. Yeah.
Jim, you're quoted in one of Ross's books, The Heat Is On, saying, quote, "Had the climate change we are now beginning to see occurred 150 years ago, the world might never have been able to sustain its current population of 6 billion people." What did you mean by that?
Well, Kurt, this follows up on Ross's answer to your last question. You know, a decade ago, it was thought unlikely that we would see significant impacts of climate change until sometime, well, quite a ways down the road. 5 years later, by 2000, the hypothetical climate impact was no longer a subject of discussion. What we're discussing are real climate impacts. And in the handful of years since then, your comment earlier about the record warming years in this period, and Ross's comment about how nations are seeing their grain yields decline, is an example of what I was talking about. If you look at the history of agriculture, it has been successful where the climate has been cooperative, and certain species that we've come to depend upon have been selectively bred over time for a rather predictable climate. And when that climate changes, as it has in history with periods of drought, and we see this in the last couple of decades in Africa, you see it in certain areas of Asia, the cultivars, the choices of crops which were selected over time no longer work. That's one of the great difficulties in Afghanistan today. It's recovering their economy with agricultural failure. So as we looked at some of the disruptions that are not at all far-fetched now, just extrapolating from what we've seen in the last few years, one could see a time in the future in which the ability to support the peoples of this world with their basic foodstuffs will be highly problematic. And some nations, this won't be affected terribly because we have enormous resilience and infrastructure that can move foodstuffs around. But my point was, had this kind of change occurred earlier, before we had any of the technology we have today to compensate for some of those failures, we would not have reached the world population we have today.
I see. Paul, in The Heat Is On, Ross writes, "In 13 years, if not before, under current conditions, their number," and he's referring to environmental refugees now, "that number is expected to double. But if predictions of increasingly severe conditions, floods, droughts, storms, and temperature extremes are realized, the tidal wave of environmental refugees will dwarf even that prediction. At that point, the number could grow to more than 200 million homeless migrants wandering the planet." I guess one of the things that pops into my mind is what's happened in South Asia with the tsunami, and we're seeing, I guess, some of what could happen. I mean, do you agree with the statistics that we could have this number of environmental refugees, and what does that imply for the future of all of us?
Certainly the December 26th earthquake and tsunami and its aftermath has been sad and tragic and sobering for all of us, looking at the kinds of things that force of nature can bring, and particularly from the oceans. About half the population on this planet are living within 50 miles of the coastal zones. Coastal zones, small island nations, low-lying areas are facing several threats from climate change. One is sea level rise, which is increasing, and it can increase storm surges There's a non-linear relationship. As sea level rises, storm surges can increase even faster. Secondly, coral reefs, which tend to buffer those coastal zones, and particularly small island nations, are facing assaults from bleaching, from warming, as well as diseases, as well as pollution and overgrowth of algae. And losing them will lose a buffer. Finally, there are more storms and the diseases in their wake. All of this is threatening low-lying areas in small nations. Could generate many, many refugees.
Thank you very much for that answer. And with that, we'll go to our second break. Thank you very much for joining us, and we'll be back in just a minute with MSL's Educational Forum. Thank you. We're back with the Massachusetts School of Law Educational Forum, and today we're discussing the Arctic Climate Impact Assessment and, more generally, global warming. Ross, you write in, I believe it's Boiling Point, about how developing countries, specifically China, whose emissions rose 208% between 1970 and 1990, complain that they must keep burning fossil fuels in order to spur their continued economic growth. First of all, why do the Chinese feel this is necessary?
Their economic growth is clearly necessary given their development needs, but I don't think they say they need to keep burning fossil fuels. I think they need a certain quantity of energy for development, and I don't think they care where it comes from. And in fact, I think the Chinese would be very, very happy if it didn't come from fossil fuels, because some of the most air-polluted cities in the world are in China and Bangkok, Thailand, and Santiago, Chile, and Mexico City, and so forth. So they do need energy. It does not have to be fossil fuel energy. China happens to have very large coal reserves that are very accessible to them. So that's really the basis on which I think they made that statement. But that said, I think it's worth noting one other statistic, Kurt, which is that between 1995 and 2000, which is a period when China's economy grew by 36%, they cut their emissions by 19%. So they're clearly aware of this problem, and they're dealing with it as best they can, given their indigenous coal supply and their development requirements.
I see. In follow-up to that question, Ross, another thing that you pointed out in the book, and I think I've got this statistic from a number of different places, and that is the United States, I think 5% of the world's population, and yet we burn 25, or we're responsible for 25% of the global emissions of carbon dioxide and other global warming type chemicals. the Chinese then point out, well, if it is the developed world that has caused this problem, why shouldn't it be the developed world that shoulders the burden of dealing with
Absolutely, and that is a big equity discussion that's at the center of a major disconnect in the Kyoto talks between the developing and the developed nations. I don't think it's a particularly productive discussion. The United States does produce 25% of the world's emissions with 5% of its population, but the United States also produces a disproportionate amount of goods for export to the rest of the world as well. So not all these emissions are for our own consumption purposes. And I think what's really important is that the whole world begin to stop looking at this as a totally defensive and sort of blame game kind of problem, and realize how they can all come together to change our basic energy diet. Because as big as an emitter as the U.S. is, it will be overtaken by China and India sometime in the next decade, and I think that's very important to understand.
Thank you. Paul, the late Anil Agarwal is quoted in Ross's book, and other developing country commentators have also said that the fossil fuel industry representatives have been engaged in what they call, quote, environmental colonialism, end quote. What do you think they mean by this? And also, what do you think they mean by how fossil fuel policies, quote, guarantee the failure of the climate convention and other conferences designed to address the real threats from global warming?
Well, the transition in China is about to open a $35 billion pipeline for natural gas from its western provinces. So to echo Ross's comments, there are attempts to move away from coal and oil and towards natural gas as the transition fossil fuel. We are dominated by oil throughout our society. We are engaged in conflicts to secure oil fields. This is a dominant force of this 20th century. We're moving into as we move into the 21st, and halfway through the first decade, we've got to begin to phase out our dependence on oil and coal, particularly. As we interact with developing countries, the dependence on oil, the price of oil, is one of the nails that is driving those economies into the ground, along with trade policies, unfair trade policies, and so on. In the 1970s, the price of oil, the tenfold rise of $3 to $30 a barrel, was one of the things that drove third world economies into bankruptcy and to debt and to extensive borrowing. So it's not necessarily a conscious policy of colonialism, but it is our dependence on oil maintains unequal structures throughout the world.
Thank you. Jim, recently concluded talks in Buenos Aires involving, I guess they were probably UN sponsored. At those talks, U.S. representatives put the kibosh on a number of different initiatives, even though we haven't even signed on to the Kyoto Protocol. And the U.S. representative there, Harlan Watson, has said that it's not fair to keep the United States out of meetings involving Kyoto signatories. How is it the United States has the power to say, we will attend these meetings and we can discourage or put the kibosh on whatever the real players want to try and get accomplished?
Just a word of background about the Buenos Aires meetings. This takes us back to my earlier comment about 1992, the Framework Convention on Climate Change, signed by the first President Bush in June of 1992, ratified by the U.S. Senate later that year. It came into force. We now have 188 nations that are signatories to this treaty. It's an international treaty. One of the provisions, Article 2 of that treaty, says we will avoid dangerous interference with the climate system. In Article 4, it says that we will return our emissions to 1990 levels. This is a time when the U.S. administration and many others were taking this matter very seriously under the administration of the first President Bush. Every year, a conference of the parties is convened. The signatories come together to discuss the status of the treaty. This is what the meeting in Buenos Aires was, one of these conferences of the parties. It was at such a conference in 1997, which happened to occur in Kyoto, that the developed world signatories said, we are not making progress, we should move ahead with some targets and timetables, and out of that came the so-called Kyoto Protocol, which has been contentious ever since. So it is entirely correct that the U.S. should be at each of these conferences of the parties. I think some of the Kyoto signatory nations are expressing concern, as you say, about the U.S. Involvement in these discussions. But the fact of the matter is there is no solution to this problem, exactly the point you were making earlier, 25% of the emissions, without the U.S. being at the table. So the U.S. needs to be there. Other nations have to figure out how to be more influential with their view on this. The U.S. at one time was a leader in this. We're not now.
Sort of a follow-up to the same question, Paul. Second of all, Harlan Watson, the United States representative at that meeting, and others have said that it's, quote, premature, end quote, to consider what to do about cutting emissions after 2012 when Kyoto expires. My thought about that was, is Mr. Watson serious?
I think as we wind down this program, it's important to reiterate that this Arctic climate impact assessment is about not just the Arctic, it's about our Arctic. It's the Arctic of our globe. And as we see melting and changes in the northern parts of in the North Pole and Greenland, we're also seeing massive retreat of glaciers throughout the world. In this winter, it is very warm in Europe. We're seeing continued melting of glaciers. What I'm saying is that scientists are looking at one another and seeing that changes we thought would happen later in this century are now becoming evident, that the rates of change are accelerating. To think that we will solve this with the Kyoto agreements today is clearly not anything that anyone believes. This is a toe in the door of a much wider room and world that has to be opened in terms of trading, incentives, and clean energy technologies. I think there is a lot of heads in the sand at this point about the reality that we are now observing, that we are now know is attributable to human activities. And I think we have to move ahead with the kind of bold initiatives that Ross Gelbsman has discussed in his books.
Jim, you're quoted in one of Ross's books as saying that, I think your exact quote was, most of the world's inhabitants will be losers. What I thought when I read that was, okay, well, what's the time frame for most of the world's inhabitants being losers, and is this more than simply Chicken Little looking at the sky and saying it's falling?
In our 2001 IPCC report, as we did a broad sort of regional cut that I referred to earlier, the region, the continent, if you wish, that just rips your heart out is Africa. Africa will be impacted as we look at all these scenarios for climate change as a result of changing climate, but also as a result of their inability of most African peoples to adapt or respond to these changes. Many of the changes that one could anticipate in climate, a developed country, the United States, for example, may be able to weather figuratively. But in many parts of the world, this won't be true. And a good example of that is what Paul was talking about earlier in coastal zones. Now, I personally have come, I think since that quote, to dislike the term winners and losers, because it does suggest that one could chart a path and smugly believe that you might be a winner while others are losers, and that's not clear thinking. If Africa, if you wish, loses, if China loses, the whole world loses. And the fact that, and again, you see this with the tsunami disaster, that there are parts of the world in which a coastal wave of that sort would not have been nearly as devastating. But it hit in a part of the world where the infrastructure is very fragile, where the damage done to property and loss of lives was truly horrendous. This is why, I mean, many of us are concerned about the ethical issues of this, the moral issues, that there are parts of the world that will be far more seriously impacted than we will sitting here in Massachusetts.
Thank you. Ross, finish it up with you. Policy proposals. Boiling Point contains a number that you talk about and then dismiss, and you have one that might work for all of us. Can you explain some of those for us, please?
A policy proposal, yes, Kurt, for sure. And again, step back and remember that we need to basically replace the world's energy system. We need to cut emissions by 70%. So we're putting out a model of 3 strategies that would work in tandem together. And if I can go through them very briefly, they involve a change in energy subsidy policies in industrial countries. They involve the creation of a large fund to transfer clean energy to poor countries, and they involve a regulatory mechanism within the Kyoto framework that would have every country increase its fossil fuel efficiency. So that on the subsidy front, the U.S. government spends about $30 billion a year subsidizing coal and oil. The industrial countries overall spend about $200 billion a year. We're saying take that money away from coal and oil, put it behind renewables. The oil companies will follow the subsidies. They'll become aggressive developers of hydrogen fuel cells and solar panels and windmills. You will also see an explosion of energy engineers and entrepreneurs coming out of the woodwork, I think, in a burst of creativity that would sort of rival the dot-com revolution of the 90s. In terms of the transfer, it's been calculated by energy policy experts that we need a fund of about $300 billion a year for a number of years to jumpstart renewable energy infrastructures in developing countries. And you can get that from a number of funding sources. I won't take the time right now. And the third mechanism that would make it all work is to have all the parties of Kyoto agree to a progressive fossil fuel efficiency standard that goes up 5% a year. That means every country would start at its own baseline right now. They would produce the same amount next year with 5% less carbon fuel, or they would produce 5% more with the same amount of carbon fuel. And since no economy grows at 5% for very long, emissions reductions outpace long-term economic growth. I think on the ground it would happen very quickly because for the first few years, countries would meet this 5% just through efficiencies, just by getting the waste out of their current energy systems. And when those efficiencies ran out, they'd meet it by using more and more renewables because they're all 100% efficient by a fossil fuel standard, and that would make the mass markets and economies of scale that would bring down their prices and make them economically competitive with coal and oil.
Thank you very much, Russ. Unfortunately, we're going to have to wrap this segment of the Massachusetts School of Law Educational Forum up. Thank you very much for being with us, and join us the next time.